Okay, so this is the review for the quiz on chapter 13. So number 1 says to expand this binomial. So we're going to do the binomial expansion. And because this is to the 5th power, that means I'm going to have 6 terms. So I'm going to write a space here for 6 terms. And I'm going to look at the Pascal's triangle, and I need the row that has 6 numbers in it. So 1, 2, 3, 4, 5, 6. So I'm going to use this row here with 1, 5, and 10, and 10, 5, 1. So those are going to be the coefficients that we're going to use. So I have 1, 5, 10, 10, 5, 1. And then I'm going to take the x term and start here with x to the highest exponent would be 5th. And this is x to the 4th, x to the 3rd, and just keep going down until we get to x to the 0 power. And then I'm going to take the 2y, and in this first term, I'm going to start with 2y to the 0 power, and they're going to increase as I move to the right. So this would be times 2y to the first. This is 2y to the second. Whoops. This is 2y to the third, 2y to the fourth, and 2y to the 5th power. And now I just need to simplify. So I know that 2y to the 0 power is just 1. So I start with x to the 5th. Here I have a 5 times a 2 to the 1st power. So 5 times 2 is 10. And I have x to the 4th, y to the 1st. In this next one, I have 2 squared is 4, times 10 is 40, x to the 3rd, y to the 2nd. And then I have 2 to the 3rd power here is 8. 8 times 10 is 80, and that would be x squared, y to, let's see what I did here. X to the, x squared and y to the 3rd. And then 2 to the 4th here is 16, times 5 is also 80, and that's x to the 1st, y to the 4th, and then my last number here, 2 to the 5th power, is 32. X to the 0 is just 1, and then I have y to the 5th. Oops, can't see all of that. There you go. All right, so all of this here is the expansion. And again, I have 6 terms. Number 2 just asks us to find the 7th term of this binomial to the 9th power. So again, I'm going to look, I need 10 terms. So I'm going to look at my triangle to find the row that has 10 terms in it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be this row. And if I want to find out which one, I want the 7th term. So I can count over here 1, 2, 3, 4, 5, 6, 7. And this would be 84. So the coefficient of this term is going to be 84. And I'm also going to have an x to the 7th power and a 3 to the power of, now these two exponents have to add up to 9. So this would be 3 squared. So I know 3 squared is 9, and 9 times 84 is 756. And that would be x to the 7th power. Number 3 asks how many ways you can rearrange the letters in the word Mississauga. So we're arranging the letters, but notice that some letters repeat. So we want our arrangements to be different. So we're going to take the total number of letters is 11. And we have some that repeat. I call them the repeaters. And I have I's that repeat 2 times. I have an S that's there 4 times. And an A is there 2 times. So if all these letters were different, I would have 11 factorial. But because some of them are the same, I need to divide by anything that's the same. So I'm going to divide by 2 factorial, 2 factorial, and 4 factorial. So I just kind of expanded this 5, 4, 3, 2, 1, and then I'm going to have a 4, 3, 2, 1, and then 2 factorial is 2 times 1 times 2 times 1. The 4, 3, 2, 1s will cancel up here, and then I can do a 10 divided by 2 is 5, and an 8 divided by 2 is 4, and if I multiply all those letters that numbers that I have left, 11, 5, 9, 4, 7, 6, 5, if I multiply those all together, I get 495. Arrangements. Number 4 is asking how many ways can we line up 8 people. So I have 8 spots that I can put people. In the first spot I can choose from 8. Once that person is chosen for that spot, I have 7 left. And then 6, 5, 4, 3, 2, 1. So this technically is 8 factorial. And 8 factorial calculates to 40,320. Number 5 says how many ways can a committee of 4 be formed from a pool of 12 students? So I have 12 students and I'm going to choose 4 of them. And it doesn't matter which order we choose a person. So if order doesn't matter, this is a combination, and I have 12 students and I'm choosing 4 of them. So it's a combination because order doesn't matter. All right, so if I just calculate this on decimals, I am gonna get 495. Oops. You guys are thinking I'm crazy with 495 up here. I looked at the wrong number. This actually, 11 times 5 times 9, 4, 7, 6, 5, when I multiply all of those, I get 415,800. I apologize for that. All right, number 6. we have 52 cards in a deck, and I want to find the probability of getting a black card. So we have to know a little bit about the deck of cards. In a deck of cards, half of the deck is black and half is red. So if there's 52 cards in the deck, 26 of them is going to be black. And that probability is 1/2. And then part B asks to find the probability that we get a black jack. So in the deck of cards, there are 4 jacks. A spade and a club are black. So 2 out of 56 are black, and that would be 1 out of 13. Oh, sorry. 2 out of 13, which is 1 out of, what am I doing here? Two into 56 is, how about if I do 2 into 52? That's how many cards are in the deck. 2 into 52 is 1 out of 26. I don't know where my mind went. Sorry about that. Number 7, consider the experiment of rolling a single fair die. So E is the event that you roll an even number. So if I look at the set of what E can be on a fair die, you can have a 2, a 4, or a 6. That would give you an even number. The event F represents an event of rolling at least a 4. So if I list all the outcomes, I could get a 4, a 5, or a 6. So in part A, we want to write the events E and F. So that's what we did here. In part B, we want to find in part A, we also want to find what is the set of E and the intersection of F. So that means they have to be in set E and in set F. So we're looking at these two numbers are in the same set. So that set, E intersection of F, has the elements 4 and 6. So we wrote the events for E and F up here. And now I'm looking for the union. And the union is an OR statement. And that means we count any element that is in either E or F. And that would be all of these numbers written one time. So 2, 4, 5, and 6. All right, so now in part C, it's asking us to compute the probability that E will happen. So the probability is in a fair die, we have the numbers 1 through 6. And for one of these values in set E to happen, we have 3 possibilities, or 3 ways that I can get an element out of set E out of 6 possibilities. So that's 1/2. So this is C. And if I am finding the probability that F happens, there are 3 possibilities out of 6. 3 in the set out of 6 possibilities if I roll a die. Same thing. I get 1/2. So now on part D, I want the probability that I have E intersecting with F. Now if I count how many are in the set, there are 2 of them, and I still have a possibility of 6 different outcomes, so this is 1/3. And in part E, I want the probability of E united with F. So if I count how many possibilities there are with E united with F, 1, 2, 3, 4 out of 6 total. So this is 2/3. Number 8. You have 6 different math books and 12 different physics books. And a student picks 2 books at random. Determine the probability that A, both are math books. So what I need to know first is the total. Because I'm working with probability, I need to know how many are there total. There's 18. So in part A, we want to know what's the probability that both books are math books. All right, so I'm choosing 2 books. So the number of math books I have for the first selection would be 6 out of 18. Then after I take that math book away, there's only 5 math books remaining, and there's only 17 books in total. So if I multiply these together, this is actually 1/3 here. So this is 5 over 51. That's the probability that both books are math books. In part B, I want the probability that both books are physics books. So the same process, I have 12 physics books, so I have 12 to choose from out of 18. If I choose a physics book, I'm taking 1 physics book away, so the second choice only has 11 physics books remaining and 17 total books. So 12 out of 18 is actually 2/3. 2 times 11 is 22 out of 51. So then in part C, it wants the probability that both books are math books or both books are physics books. So when I see the word or, this tells me I'm going to add those probabilities together. Okay, so the probability that they're both math books is 5 out of 51. And the probability that they're both physics books is 22 out of 51. So that would give me 27 out of 51.